Hi everyone, I'm Yi Hong. Today I'm presenting my individual project, an IoT smart home environment and climate automation system. This system addresses indoor climate safety and automated lighting efficiency. It bridges the gap between local edge automation and cloud analytics by connecting a Node MCU ESP8266 directly to the Blink IoT platform. Looking at the physical setup, I have established a direct point-to-point connections. Environmental tracking is handled by a DHT temperature sensor and humidity sensor connecting to pin D4. For ambient light tracking, a photoresistor is wired directly to analog pin A0. For our automated outputs, I have an LED lamp on pin D5 and a buzzer on pin D6 serving as our climate alarm. Now looking at the Arduino code, we have at the top the template ID, template name and authentication token at the top. The libraries included for the ESP8266 to work in conjunction with the Blink IoT, my pins addresses, my threshold which is 40 degrees for temperature sensor and a light threshold of 300, and these are the values to put for say the light switch and also the countdown for the buzzer. Here's the Wi-Fi, the input outputs, and the Wi-Fi and password for the ESP to work with the IoT. Now, and here are my read sensors for the humidity, temperature, and also the light level. Over here is basically a countdown of 5 seconds. When it hits above 40 degrees, there will be a countdown of 5 seconds where the buzzer will keep on buzzing, and once it hits below 40 degrees, this buzzer will count down every second over here, and after that 5 seconds, it will turn off. And here are the light switch to indicate whether the LED should turn on or off based on my input readings on Blink IoT. Now we move on to the Blink IoT. So let's start with the lamp. So currently this is the light reading, and irregardless how dark it is, it will not turn on. But if I switch this on, currently it's not exactly dark enough, but if I put it bright enough, you'll see the lamp turns off and my reading skyrockets, and once it goes below the threshold, it will turn on. And if I turn this off, the lamp will be off irregardless of how bright it is, of how dark it is. Next, we have the temperature and humidity sensor, which are constantly reading every second. Currently it's 26.7 degrees, which is why the buzzer is not turning on. But once it goes above 40 degrees, the buzzer, as you can hear, is buzzing, and my gauge has turned red because it has gone above 40 degrees. And if we let it cool down, now that it's gone below 40, it turns green and the buzzer stops buzzing. By combining local edge processing with a central cloud dashboard, this system provides standalone safety protection with remote monitoring visibility. The implementation functions flawlessly and meets all assignment guidelines. Thank you for watching.